All right, folks. I understand that you have a web-assigned question that has to do with center of mass, and we didn't have a chance to do that yesterday, so I wanted to give you a brief overview. I'm going to send you 3 videos. One is a description of the formulas for center of mass. The second one is an example of finding the center of mass of a uniform rod. And the third video is going to be finding the center of mass of a triangular solid. All right? So here we go. This is video number 1. I just want to talk about the difference between finding the center of mass for a discrete number of masses, discrete blobs of mass, versus a continuous shape. So discrete means separate. So if I have separate little blobs of mass in space, and I want to find the center of mass of those, I just have to pick a coordinate system, so x, y, and then I can add up those little masses and their position and find basically the average mass in the x direction and the average mass in the y direction. So center of mass is equal to, and let me give myself a little space here. Okay. Center of mass is equal to the sum of each little mass times its position on the x-axis divided by the total mass. And the y center of mass looks very much the same. It is the sum of each little mass times its y position divided by the total mass, all added together. So if instead of having a bunch of little blobs of mass, we have a discrete, a continuous distribution of mass, like you would see in a uniform rod or a rectangular shape or a circular shape or, for instance, a triangular shape, you have to instead use the integral function, and instead of adding up discrete points, we're going to be summing over little pieces of mass. And so the formula looks like x, center of mass, for a continuous object is going to be 1 over m, and that's the total mass, times the integral over x, since it's the x center of mass, of x, times, instead of mass, we're going to use a little piece of mass, dm. And the y center of mass is the same. It's 1 over the total mass of the object times the integral, so we're adding up all these little pieces of y times a little piece of mass. All right? The hard part is going to be figuring out what to put in for this little dm. It's going to involve some variables that we have to sort of manipulate around. And so we're going to, in the next video, I will do example 1, okay?